Okay, so this morning we talk about the community version and ultimate version of IntelliJ. So if you're using ultimate version on your left, you're supposed to have this Spring initializer, Maven, and all these other things. But if you're using only a community version, probably you can only see Java and some of the basic thing can create it in here. For the first 1 or 2 weeks, we only need to use this Java one. So let's click on this Java, and on the drop-down menu from the right side, you can choose your SDK. Okay, so this morning I asked everyone to download and install Java 11. I'm not sure if everyone have some other versions in here, but is everyone able to find out Java 11 in here? Or let me ask you in another way. Is there anybody you cannot find Java 11 in here? I'm keep seeing people join and quit, so I don't know who is here. And there are many people, so probably it's hard for you to answer. But if someone who cannot see Java 11, please let me know. Okay, if you couldn't see it, then use new to find your JDK. So where is the JDK installed? By default, if you're using Windows, then JDK is installed in your main drive. For example, for me, it's C drive in the program files, and you have a Java folder. Inside Java, you're supposed to see this JDK 11. For me, it's 11.0.16.1. For you, probably a little bit higher. And then you select it, it's okay. If you're using Mac, then in Mac, the location is this by default. And I hope nobody change your JDK location. Okay, so whatever platform you're using, choose the JDK folder. You don't have to choose anything inside. As long as you click on this, you're good. Since I already have it, so well, I don't have to. You choose 11 and then click on next. My IntelliJ version is a little bit old, so probably a little bit different in here, and I don't do anything else. And I'm gonna create a project. I'm gonna call it just call it Java. And the project location, you can choose this folder we just created. We just created a folder called Backend Java. You can choose this folder from here. Okay. After that, I'm gonna click on Finish. So I know even we have a lot of students in this batch, but if anyone has any issue, please do not hesitate to stop me. Okay, you can just directly start talking, unmute yourself and talk. And let's finish. My computer is a little bit slow. Bear with me. So you're supposed to have a Java project created on the left side, and you will have a folder called src, and there's another folder called IDEA if you're using IntelliJ. If you're using Eclipse, then there's no such folder. Then in the src, hoping everyone already finished this step. Okay. And in the src, let's right click, and let's create new. Any question? Or someone's?
A quick question. I don't have the Java choice on when I try to new a project.
You don't have the Java choice. You click on
Yeah,
File, New Project.
yeah. It's just Java F. Let me see. Of,
Java application or something.
yeah, it's just Java FX, no Java.
You only have this.
Yeah,
You don't have Java on top.
yeah.
Are you using the
Ultimate version.
you're
Yeah,
using Ultimate version? You still don't have it.
yeah.
Can you please share your screen?
Oh
Anyone,
yeah.
anyone, please. Always ready for share the screen. Okay. Even we have. I want everyone started. So everyone help. Stick. What do you?
Can can you see my screen now?
No,
Okay.
I see you're sharing, but it's not coming. So,
Oh, that's weird. Let me do it again.
uh,
Teddy J. Shit. You see now? Or I can just share my whole screen.
yes, please, if you can.
Okay. Give me a second. Entire screen here. Yeah. So there's no Java here.
I think it's not your uh, screen. I think it's we cannot see your screen share. I think it's something wrong about your
Oh,
else in the screen.
maybe because you are sharing the screen. I'm not sure.
No, in Discord we can have multiple people share the screen.
Okay. That's weird.
Or if you do a screenshot and put in the general channel so that we can
Oh
see.
yeah, sure.
Oh, uh, couldn't find it anywhere downstairs as well.
Nope. Let me put in the general channel. Yeah, just put it in our channel.
New project. Then it should be just the new project. I think by default is the Java project.
Okay, so this is the. So I don't need to select Java. Got it.
Uh,
I think your Java is already selected.
no, that's the language you selected because you can choose Java, Kotlin, Groovy, or some other things. I believe you're using Mac, right?
Yes.
Probably just choose this. By default, it is Java.
Okay, got it. So no need to select Java.
Yes,
Right.
you change the name and change your location.
Got
Location
it.
to
Thanks.
place the folder you created.
Okay, got it. Thank you.
And try. All right. Uh, we hope everyone can follow. Okay, so if someone is having a small issue, we can try to fix. If we don't have enough time to fix it during the class, we can fix afterward. So in the SRC, let's right click a new a package. So some student, if you never have work experience before, maybe in school you would like to create your Java file directly in the SRC folder. But once you go to the industry, there's no way you can directly put your Java class in there. We always put our class in some package, and the package has to follow the naming convention. So since we are currently working in Mercury, and Mercury is a company, so the package we're going to create it in here should be called com.mercury. Okay, so in the future, if you work for a different company, then you will call com dot whatever the company name, and then dot something else. Or if you're working, for example, you're creating a project for a government, then probably your package can call gov dot like New Jersey dot whatever. Okay, so in here, let's create a folder called com.mercury dot. So the last part we can name as whatever we want, but most likely lowercase. Let's call it basic. Okay, and in here, let's create a very basic one. So actually, there's a very funny question. So if we don't have IntelliJ, okay, if we don't have IntelliJ or Eclipse, during the interview, I just want you to use Notepad. How many of you guys confident enough to write a Java version Hello World? Is there anyone who could not finish the Hello World? I'm not expecting anyone to answer, but based on my experience, a lot of you guys probably couldn't. So let's create a hello world. I mean, in IntelliJ, there's easy way to create. So let's create a Java class. Let's call it hello world. Okay, when you name a class, remember, name the class in camel case. Start with capital letter. For every word, all the other letters supposed to be lower. Just like this, hello world. Okay, and inside the hello world, you're supposed to have your main function. You don't have to type the entire main function here because in IntelliJ you have an easy way. You just type the letter M. It's going to show you this main function. You can enter or select it. It will show up. Okay, so this main function looks like public static void main with a string array as an argument. And this one, you can call it whatever you want. And you should type sysout in here, but whatever you're trying to do, you can type easily as SOUT in here, sysout, and then you can basically type hello world in here. Okay, so let's run it. How to run? By using IntelliJ, you're supposed to add a configuration. Basically, you see there's a button. This button, you're supposed to be able to click on it and run it. However, whatever you're trying to click in here is actually running this configuration you have configured on the left side. But right here, you haven't configured anything. So the proper way to do it is to click on this button and to create something you're trying to run. What are we going to run? We're going to run a Java application. So you're going to create an application and configure the entire thing in here. For example, where's your main class? What's the VM options? Everything here. Okay, but there's an easy way for you to run this. So on the left side of your main function, there's a button. You can click on it and it will give you some different options to run. And each button is doing exactly the same thing as the button shape in here shows. Okay, so by default, you can select the first one, run it. You're supposed to have this little hello world in running, and you're supposed to be able to see hello world displayed. Okay, for me, I'm just type HW in here. Okay, is there anybody who could not see this run and displayed? Anybody? Okay, if nobody, I assume everyone have a good environment to use. All right, now we can officially start the training. So first, I'm going to ask you some question here. Okay, now I'm expecting someone to answer. So when we learn, we're going to learn Java in here. Okay, now what are you expecting to learn from here? Can anyone tell me? Since most of you guys have internship experience, can someone tell me
the frameworks?
The frameworks.
Java frameworks.
Okay. Anything else? Is there anybody want to learn algorithm? Anybody?
Yes.
Okay. Unfortunately, we're not going to talk algorithms. Okay. Algorithm is a skill that required during the interview. But the skill, I mean, yes, there's a lot of different kind of algorithm training, but we don't have enough time for us to actually train algorithm in here. And when we talk about algorithm, there's a lot of different branches inside. And I hope everyone can practice the algorithm question by yourself every day. So during the real interview, you can have experience. And I know a lot of you guys already practice on LeetCode. That's good. And I hope if you never do that, please start doing today. Okay. So for algorithm, I can give you a hint how to do it. There are two things you should follow, and then you can do algorithm quicker. The first is to learn data structures. Okay. So data structure is like the tool for you guys to work on the algorithm. For some algorithm question, if you're never familiar with the corresponding data structure, then there's no way or very hard for you guys to finish the algorithm question. So first, get familiar with the data structures. Second is to remember to do summarize conclusion for whatever the algorithm question you used to work on. Okay, always review the previous algorithm question you've been working on, and that's going to give you enough experience for you to continue. So when we talk about algorithm, there are 3 steps you should remind yourself. The first step is if there's no algorithm, it's basically like, for example, I tell you what to do. Okay, I give you a question and I tell you the solution. but I'm not telling you the code. I'm just telling you how this algorithm is going to work. So basically, from a solution, are you able to finish your code? Okay, this is the first step. And we expect everyone who's currently in this batch could do this. Okay, means it's not actually an algorithm question. It's basically, I'm telling you what to do. Are you able to write the code? This is the first level. Second level is, there is an algorithm question. Are you able to give me a solution? No matter the solution is good or bad, are you able to give me the solution? Okay, now this is actually the algorithm part. Now the last part is, if you have a solution, can you give me a better solution, a optimized solution? Okay, so basically these are different steps. So to practice the algorithm question require you to have at least the first level. Okay, so otherwise you're not actually working on algorithm. Otherwise you're just working on the coding skill. So once you are confident enough to do the first step, and then you can start practicing the algorithm questions. Okay, and then when you do algorithm, just do whatever I said, data structure, and practice different type of algorithm questions, and then remember to summarize everything. Okay, so in here, what are we going to provide in here? So in Mercury, no matter the front end and back end training, we always start from the core language. For example, in the back end, we start from core Java. In the front end, we start from core JavaScript. And after that, we're going to talk about the different frameworks. So what is framework? Framework is basically like a tool, or some other people already finished a lot of piece of code. And for us, whoever the user trying to use the framework, we just fill in some of our own information into the framework, and the framework is supposed to run as whatever we're expecting. So we already have a big frame. We just put our own information inside. Okay. So why we need to learn framework? Because in industry, there's a lot of framework is widely used. If you're not familiar with the framework, or if you don't know the internal logic of the framework, then it's hard for you to get on to the work. All right. Next, another question, technical question. When we talk about Java, there's several keywords we cannot avoid. Is JRE, JDK, and JVM. Can anyone tell me what are they and what are they used for? Anybody?
Java runtime environment.
Java runtime environment is a JRE, right?
The Java development or development kit,
JVM.
and Java virtual machine.
Okay. Do you or any other people know what are they used for?
I'm not so sure on what they're used for.
Anybody else know? Maybe anyone who even know any one of it, you can try to answer. You don't have to know all of them.
The Java runtime environment is for like you need to have them downloaded before they could run a jar file
To run a jar file,
because it has all the libraries and stuff.
has all the libraries inside. Okay. Anyone know the others or want to talk more about the JRE? We encourage everyone to speak, okay? This counts as your class activity.
Remember that the GLE consists of JVM.
What's in the JVM?
JRE consists of JVM. The JVM is concluded in JRE.
JRE include the JVM include the JRE. Is this what you talk about?
JVM is included. Included
In JRE.
Yeah.
Okay.
So for GRE, it's probably also contain the debugging tool.
Debugging tool.
And GRE contains JDK and JDK contains JVM.
GRE contains JDK and JDK contains JVM. Okay, all right, let's talk about what are they, okay? First, GRE, based on the name, called Java Runtime Environment. Based on this name, it means in the runtime of Java program, you need this environment. Basically, without this environment, your Java code cannot run, okay? So in the morning, I was asking everyone to download JDK 11 and install. So actually, if you download some old version of JDK, for example, I'm asking you to download JDK 8 and install. So when you install this JDK 8 on Windows, I'm not sure JDK 11 currently in Windows, okay? So there will pop up a advertisement showing this, saying over 3 billion computer have Java installed. Okay, right now probably the amount is even higher, but whatever. It means in the entire world, there are over 3 billion, large number of computer, including, I believe, including phone or something, okay? All these devices has Java installed. Now, what are actually installed on these 3 billion devices? GRE or JDK or JVM? Anybody know? Or take a guess?
JRE?
JVM.
GRE, JVM, okay.
I guess JDK.
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 All right. Okay, no guessing. So first, over the 3 billion computers, of course, is the people who want to run Java code, right? It's not like our Java developer is using all these 3 billion computers. Most likely, most of the people who use the Java program, they are not developers. So on these computers, we need to run Java program. Now, to run a Java program, what do we need? We need the runtime environment. So basically, without JRE, you cannot run a Java program. And also, if you go to this www.java.com, and then on the first page, it will show you to see, do you have Java installed on your computer? And on that page, if you don't have Java installed, it will ask you to install. And it's actually checking, do you have JRE? Okay, basically it's trying to see, are you able to run a Java program? So without JRE, you cannot run a Java program. And I believe every one of you have heard that Java is cross-platform. What's being cross-platform means when whoever, me or you, whoever write a Java program, no matter what computer we're using, for example, I'm using Windows, you guys may be using Mac or Linux, whatever different computers. I write a program on my Windows computer, I directly give my code to you, and you can start running it in your Mac computer. Why this Java program can be run in different computers is because no matter where you're running your Java program, it actually requires this JRE environment. So JRE in Windows and in Mac are different. But once you install this different JRE in your own computer, the program we run on top of JRE means our own code can be the same. Okay, so our code are cross-platform, but JRE is not. JRE is provided by the company, but Java right now owned by Oracle, by this originally by Sun company, right now owned by Oracle, by this Java company. So if you want to run Java program, you need this. Now what's JDK? JDK called Java Development Kit. Based on this name, we know this JDK is used for development, and who need to do the development is only our developers. Okay, so JDK is something created for our Java developer to use. If you're not a Java developer, you're just using a Java program, you don't need JDK. Now the question is, for our programmer, do we need JRE? Of course we do. Okay, so we are the programmer. Of course we need to run our own Java program. So JDK is a development kit for us to develop Java. So JDK actually include JRE inside. Okay, it's not JRE including JDK. It's not. It's JDK include JRE. Now let's take a look. I can give you an example. So if you look at my computer, in my program files, I have a Java folder in here, and by default, JRE, JDK, they all can be installed in our computer. You can have multiple versions in here. And you can see in my computer, I have two different versions of JRE. It's an old version JRE 7 and also an old version JRE 1.8, short for Java 8. Now, if you look at my JRE, I can open, even this is a little bit old, but pretty much the same, okay? So if I open the JRE, you can see in this folder, I have a lot of different files like the welcome page, release, readme, all these, useless. Beside this, I have two folders in here. One is called bin, the other one is called lib. Lib, short for library. So basically, whatever in here are the libraries to support this current program to run. Means if your JRE trying to run, if your Java trying to run on JRE, you need the support from this lib folder. And what's mean bin? Actually, in the future, if you go to some website to download the software or download something, there's always given an option saying to download binary. Okay, bin is short for binary. What's mean binary? We know binary is represent like 0, 1, 1, 0, something like this, right? But binary in here actually means executable. So we know in Windows, if you have a file called .exe, that is an executable. Or in Windows, you can have some other type file can also be executable, BAT, or some other different type. Okay, but in Mac, if you're using Mac, then exe is not executable. So bin here means the file inside are executable for your current platform. For example, I'm using Windows, so you can see inside here are most likely exe files. These are executable. Okay, so we can see these are basically whatever we have in the JRE. Now let's take a look what's in the JDK. I was opening this JRE 1.8, so I'm also going to open a JDK 1.8, and let's see what's inside. If you open this folder, you can see I also have a lot of these files, and after that, beside all these, we also have a bin, lib, and we have a JRE folder in here. Okay, so JDK has a JRE inside. If you open the JRE inside, you can see pretty much the similar structure as the JRE I installed individually. It also has its own lib and bin. Okay, so beside this JRE, JDK has some other folders. For example, he has his own bin folder in here, its own lib folder in here. Okay, so in this bin folder, it also have a lot of executable, but more than whatever we can see in the JRE folder. Okay, so basically, JDK include JRE, not the other way around. Okay, now JVM, let's leave for a little bit. Let's talk about these first. So JDK and JRE are basically the thing we need to do, we need to use to start our development. Now, I believe when you were still back in school, when you the first time learned Java, I think your instructor always tell you to configure the path for configure the system environment for you. Okay, now let's talk about why do we need that, or do we actually need it? So we know we have an IDE, we have our hello world. We click on this button, it's gonna start to run. Now let's say this, if you don't have IDE, okay, you don't have IntelliJ or Eclipse installed, you only have JRE installed on your computer, and you have only Notepad to write Java code. Is there anybody know how to run a Java program without IDE? Anybody?
You can use a command prompt,
What command do you need?
the Java command.
Java command. Okay. Now before you run this Java command, you need to write your Java hello world program in here, right? So after you write a hello world program, what file format or what the file name you're supposed to save it as?
Save as a Java file. .java.
What will be the file name? Random name?
Hello world.java.
Hello world.java. You're right. Okay. Can you save it with some random name? Let's say this abc.java. Is that okay?
Yeah, you can still run it.
Okay.
No, I think
No, you cannot. It should be.
I
It
think
should be
shooting
the
class.
Okay. You're right. You guys are right. Okay. You're supposed to have exactly the same name as your class name. Let's do a test. Okay. For example, right now my file called hello world.java. So if I change the name of here, it will give us an issue. Okay. But does that mean you cannot change the class name of a file if the file name doesn't change? You can do some trick in here. For example, I'm removing the public. Okay. Then I can change to whatever I want. Okay. But if your class is a public class, which is by default is a public class, then you have to have the same name as your file name. But if I'm creating another class, for example, class A, then it doesn't matter. Okay. Now, many people ask me, like, what if I have two public classes? Apparently, you cannot. Okay. So in any Java file, you don't have to have any public class. But if you have public class, that public class has to be the same name as your Java file. And can I have two class in the same file called the same name? No. So basically, in one Java file, you can have at most one public class, and that class should have the same name as your Java file. Okay, so you have to name your Java file as hello world.java. Now you have this file already. Can you use the Java command to run it?
I think you have to compile it first.
How to compile?
Java C.
Java what?
Java C and the name
Hello world. You need
dot Java,
okay, and after that, what happens?
and
It will
You will have
You are showing the .class file. .class file.
have a hello world.class file, right? Now after that, what are you gonna do?
Java hello world. Class.
This
Dot-
you
dot
don't
class.
you don't need this .class. You just directly Java hello world.
Okay.
Okay. Now as long as your file is written in the correct way, this can run. Now here's a question. Okay. Here's a question. You're running Java C or Java. What are these? What is Java C and what is Java? I heard people saying these are command. You're using Java command or Java C command, but what is a command? Let's say this. You go to Best Buy, you buy a new computer. Okay, this new computer is fresh new. They only have Windows or Mac installed on the computer. Nothing else. Never have anybody installed any Java, like JRE, JDK. Nobody installed anything on it. Can you run this? The answer is
no.
no. Okay. Now to run this manually by yourself, what do you need to install on your computer?
You have to configure the system variables.
Now before you configure the system variable, do you need to install something or you directly configure it? That's gonna work.
You install the JDK first and then configure.
Yes, you need JDK. Okay. Now, what is Java C? Java C and both Java, they're command. What is command? Actually, command is a program. Okay, it's a program. So when you type a command in here, you're actually invoking a program. Now everybody know you have your default command. For example, in Windows, I can type dir. In Linux or Mac, I can type ls to show me whatever the file or the folder I have currently in this directory, and then I can type cd Even you're not familiar with the command in here, but I'm pretty sure cd, everybody know. Cd means change directory. I can type cd space with my directory. For example, I'm going to videos, and it will actually jump to this videos folder. Now, everybody knows cd is a command. It's built in your computer. But what is cd? What is actually a command? When you type cd or videos, what actually happens? Why change the here? Is because cd is actually a program. Okay, when you type in here cd, it means you're trying to invoke this program. And what is this videos you put in here? Is the parameter you send into this program. So you're actually using this parameter to invoke your program. Okay, now this program runs and it will switch from that directory to this directory. It's actually just to display this for you to easily use. Computer doesn't care where are you, but cd is a program for you to know where are you, to change you to that directory. Same thing, when you type Java or Javac in here, you're also invoking a program, but this program is not in the computer by default. It is under the JDK or JRE. So if you have JRE, inside the JRE bin folder, you will be able to find Java command. Okay, you can find Java because this command is the command for us to run the Java program. Now, JRE is designed for people to run Java program. So JRE, of course, is going to contain java.exe. But do we have Javac in here? If you look at this folder, you will not be able to find Javac. What's mean Javac? Javac is C short for compiler. Okay, I believe everyone heard about compile. So what is Javac? By using Javac, you're actually invoking the compiler. Now, I've heard people is saying that JVM. What is JVM used for? Some people say JVM is used for compile your file. It's actually wrong. How to compile your file? Your file is being compiled by this program called Javac, of course, with the libraries behind this program. Okay, so this is the compiler. So what's mean compile? Compile means use the compiler to convert your human written Java file to a machine readable file, class file. Okay, so our own Java code is written by us by using our Java language to put in a Java file, and that file is able for our program to read, to write, but the machine, the computer, doesn't use that file. For that file to run, we need to use the compiler to compile it to a class file. Okay, so this step is done by the compiler. Now, when they do this compile work, is there anything that JVM involved? No. Or let's say from our current understanding, we can say JVM is currently not involved in here. Okay, we're going to talk about JVM later. But right now, remember this, JVM does not responsible for compiling your Java file. So once we have this, let's take a look at this JDK to prove what I said is correct. Inside the JDK, inside the JRE in the JDK in the bin, you still couldn't find this Javac. You only have Java and something else, but you don't have Javac. Okay, but in the JDK bin folder, right now I'm in JDK only. In the JDK bin folder, you're able to find Javac. So what is Javac? Is a program. Okay, now if you just buy a computer back from Best Buy, you just install JDK and you directly type Javac with your file name, are you able to directly compile your file? The answer is not, because it most likely going to give you something display like this, saying Javac is not recognized as an internal and external command. Maybe you're thinking, I'm typing Javac in here, of course, the computer doesn't recognize. But what I'm telling you is, if you just install on your computer, even you type Javac, you're still going to see the same thing in here. Okay? The reason is, it's not like the default command like cd or dir. is already known by the Windows. What are these mean? Java C is a command introduced in JDK, which Windows doesn't understand by default. So we need to do is to configure it in our system environment. So we can directly type environment in here if you want. Okay, in Mac, you don't have to do anything by default. Once you install it, will configure already. So in Windows, there's an option called Edit the System Environment Variable, and there's a button environment variable. If you're using Chinese system called 系统变量, 环境变量. And in here, you can have your own variables and you have system variables. So why it's called variable? What are these actually? So as you can see, all these are key value pairs. Even it's called variable value, but basically key value pairs. If you've been using map, hash map or something in Java before, you're supposed to know key value pairs. Okay, so it's basically you define a variable, and this is the corresponding value. Now in your system variables, there has one variable called path. This variable is in there before you configure it yourself. It's a default system variable, but you can modify this. You can edit it, and you can see there's a lot of variables, and there's a lot of things as part of this path. And for our Java developer, if we want the Java C to be can be used by default in here, you need to put the JDK bin folder, this folder, into this path, because whatever you configured in here, next time, if when you type in here you couldn't find the command, you will search through this list. That's why for me, this is what I put long times ago. So that's the time I was still using JDK 8. So I put the JDK 8 in here. Okay, I put JDK 8 bin here. For you, if you want to run it manually, at least for fun or something for you to try, you can put your JDK 11 bin folder in here. You can create a new one, configure it in here. Okay. Now there's another one I believe everyone's familiar with called Java Home. So what is this? When you define Java Home, you also just provide the JDK location. That'll be good enough. Okay, you don't have to give to the bin folder. You just directly give the JDK location. Now, what is Java Home used for? So some old Java program, they require you to have this variable defined in your system. For example, some old version of Eclipse. I'm not sure if Eclipse still requires this, but in the old time, if you're trying to run Eclipse and you don't have this Java Home defined in here, then your Eclipse cannot start. Okay, so in the old time, a lot of Java programs require you to have this variable defined in the system. So they will, by default, go to find this variable and retrieve whatever they need from the JDK or JRE. Okay, but right now, less and less Java programs require this. Some of the big Java programs still require this. Okay, so it's not necessary until you see some Java program required to have this, then you can configure it. All right, so basically once you configure that, you can run Java and Java C. Just trying to clear everything before we continue to move on to the knowledge part. So this is basically JDK and JRE. Now, the JDK version I'm asking you to install this morning is JDK 11, or we can call it Java 11. But what version of Java is actually out there? Let's take a look. Okay. If you look at JDK, if you look at this Oracle website, you can see Java already have 19 and 17 available. Basically, you have already to Java 19. Why are we still using Java 11? So this Java was started from version Java 1.0, okay, all the way to 1.1, 1.2, 1.3, and then all the way right now is 1.19. Okay, when they say Java 19, it means 1.19. Okay, now we are currently using Java 1.11. So why are we not using the other versions in between? So from 1.0 all the way to 1.7, every version in between has been used in industry for at least a long period. Okay, after Java 1.7, there's a significant change in Java 1.8. We say significant, but it means compared to the previous version. Okay, but still, it's not that big, but it's big. So after Java 1.8, when it goes to Java 1.9, they modify something that, when we write our code, when we update our Java version, we're supposed to have that backward compatible. Means whatever the future version of your code is supposed to be able to work with your previous version of code. However, in Java 1.9, it's not. Okay, so which means if you originally used Java 1.7 and now you move to Java 1.9, maybe some of your code cannot work, and that's very bad. And in Java 1.10, they're trying to fix it, but still having this issue. They're working on 1.9, but still having bad issues. So Java 1.11 is basically a version directly from 1.8, and that is a version that everyone like it, back to the correct way. And is still widely used in the industry. And right now, I can say half of the company out there is using Java 1.11, and the other half, let's say less than half, is still using 1.8. Okay, so 1.8 and 11 are still popular outside. 90% of the companies still using this. Now, what about 1.12 or 1.3 or some other versions? Does that mean if there's a version, does that mean there's a new version shows up, then company gonna use it? No. In the industry, everyone trying to make things stable, make sure there's no problem. So from 1.12, from 1.11 to 1.12 to now, Java has changed. Originally, this thing like shows up like every once in a year or 1 or 2 years, there will be a big version. But right now, every half a year, there will be a new version of Java. So Java version going to increase a lot. But is every version going to be stable, going to be used by the industry? No. Only the long-term support version can be used. So after Java 11, the next good version is 17. Is 19 a next good version right now? Maybe not. Okay. So Java for the Oracle is encouraging everyone to move from 11 to 17. But since every time not everything started being tested, so most of the companies still prefer to stay in 11 to hold back a little bit to make sure everything still runs good. That's why we are using Java 11 in our training for now. Okay, but during the interview, a lot of people like to ask you the knowledge between Java 1.7 and 8. So in the training, we're going to have a special session just to talk about the different happens in Java 8. Okay. Now between Java 8 and 11, there do have some change, but not very much. We're going to talk a little bit about that as well. Okay. So these are the Java version. That's why we're right now using Java 11. Now, the next thing, let's talk about JVM. This is actually, we're going back to our code. Okay, I'm going to modify my code a little bit. Okay, everybody know I can directly print this string in here, but I'm not going to do that. I'm going to do this string. Let's say str equals new string hello world. And I'm going to put str in here. I'm pretty sure everybody knows that if you run the code, you're going to display pretty much the same thing, hello world. Okay, so why am I doing this? Because I want to use this line and the other thing in this file to explain what is JVM. I'm going to draw a picture in here. JVM means virtual machine. Okay, virtual machine. So if there's a virtual machine, then we must have something called actual machine. So what is the actual machine? Actual machine is the computer you guys are currently using, including myself. I'm currently using my computer. That's the actual machine. So in this actual machine, there's a lot of components. There's a lot of things inside it. We're not focusing on like everything, but as a Java developer or as whatever the JVM cares, is this. So we can consider the actual machine have some important piece inside. Okay, for example, you need to have disk. Okay, so in the actual machine, if you want to run any program, you need to have that software or the program on your disk first. Now people are saying I can just directly play a game online and can watch the video on YouTube. I don't have to install any video playing software on my computer. Yes, but you need to have the browser installed in your computer, right? You go to YouTube, you play game online or some website online game, at least you need a browser. So for the browser, you also need to install on your disk. If you're doing something else, for example, you're running a program, for example, Discord, or you're running your IntelliJ, you need to install on the disk first. So maybe you have different program. For example, you can have your game on the disk. You can have your Discord installed on your computer. Also, if you want to run your Hello World, you need to have Hello World program in your actual machine. Now, when you run the program, no matter you're running a game or you're running a Hello World, is the computer going to run your program directly on the disk? Anybody?
No, definitely no.
So where is the program going to be run?
In the memory?
In the
Yeah,
right? Now, but the program currently is in the disk. How to run it on memory? Anybody? Okay, we're going to load it. All right, what's mean load? Basically, find this program you're trying to run, copy to the memory. Okay, now different software, different program to run require different memory spaces. For example, if I'm running a big game, of course that game going to require a large amount of memory. If I'm just running my Hello World, which is a very small program, I just need probably a little bit of memory. Okay, but different program, if you want to run it, you're going to copy the program to the memory. Now, even the program is copied to the memory, who is actually, or what part in your computer is actually executing this code? Anybody knows?
CPU.
CPU, right? CPU. Everybody know the full name of CPU? Called Central
Processing unit.
Processing Unit, right? Central Processing Unit. Now, CPU can consider the actual worker to work on your program. Now, there's a problem. Is, for example, if I have a program, for example, okay, I have this Eclipse program. I double click on this icon, okay, or I double click on whatever the icon in here. Why I double click, it will run Eclipse. Why I double click on this, it will not start a IntelliJ. Who knows I'm double click on this icon, it will run an Eclipse program.
Because it has different location.
I know, but who's telling the computer when I double click on that icon, please start Eclipse, but not some other program? Basically, the question is when I double click, who received this command?
CPU.
No, CPU does not directly receive it.
the operating system.
Exactly. Okay. So whatever your operation is captured by the operating system, OS. Okay. So what does operating system do? Operating system do basically two things. First is basically able to get information from user. Second, based on this user command, it will operate the computer. Okay, so basically operating system is an interface between you and your computer. That's why when you buy a computer, the first thing you're going to install on your computer is an operating system. Without this operating system, there's no way for you to operate your computer. Okay, so you have the operating system for you to do that. When you double click on the icon, operating system will realize you're trying to play the game or run a program. He will go to the disk, find out this program, and is the operating system responsible for run this game or run this Discord for you? Yes. But operating system is, he doesn't want to run everything by himself. Instead, what he's gonna do is, he is running the thing by himself, but what I'm trying to say is he will allocate a piece of memory for this game, allocate a piece of memory for Discord, allocate a piece of memory for the other program, and everyone beside the memory, each program could also use some other things. For example, you're gonna use some piece of CPU. Basically, you can use some resource of the CPU. You're gonna use some of the bandwidth if you need to get online. You also need to use, maybe you're gonna save more things on the disk, or you're gonna use some of the cache, whatever. Okay, so and of course including the memory, all these together, the resources together, we can say that's the thing for your program to run. And all these resources for this program assigned by this operating system, together we can give a name, call it a process. Okay, that's why in Windows, if you right click in here, there's a task manager. You can see the first tab in here is called processes. Inside, you can see there's a lot of process listing in here. For each one, it has a name to indicate what is the program is actually running. It has the CPU usage, memory, disk, network, GPU engine, all these things together. All these, we call it resource. All these resources together, we call it a process. Okay, so we can say this process is created and managed by the operating system to run your program. We can say the process is to run your program. Okay, so basically, you want to run a program, you need to have a process. What is a process? Then we can say, in our own mind, we can understand the process like a little person. Okay, a little guy. Now this guy is able to use the memory, to use CPU, to use all these, whatever the operating system assigned to him, to run your game, to run the Discord, to run the Hello World for you. Okay, so we can have multiple processes, like the operating system is hiring a lot of little workers to run each program for me. Okay, so that's basically why we need an operating system. Now, CPU, what does CPU do in here? So basically, operating system will tell CPU what's the time or what's the program CPU need to work on which project. Okay, CPU can be also considered as a part of the resource. So we can ignore the CPU in here. You can see CPU is like part of the resource. Together is part of this little guy. Okay, so everything together is managed by the operating system. So this is what actual machine is doing. Okay, well, in actual machine there's a lot of things, but for us we only focus in here. Now let's talk about what is JVM, virtual machine. So we already know game, it need memory. Now same thing, to run a Hello World, which is a Java program, we also need to have our memory, our disk, our bandwidth, our CPU involved. Okay, so this piece of memory, since I don't have enough space in here, it's small, I'm gonna draw this piece in here. Okay, so let's say this is the memory part for our Hello World to run. Now, to run Hello World, this is a Hello World program. We know we just directly run Hello World. Okay, now let me ask you a question. Maybe everybody see this before every day, but think about it. Okay, does everyone know what is system? Does anybody know what is the system? What is this? Is this a interface class or something?
It's a class.
This is a class. What is out?
It's a method within that class, or it's a subclass.
Is it a method or a subclass?
A static variable.
It's a variable. All right. Why I say it's a variable? I heard someone saying variable. Why? Because in Java, if you're trying to invoke a function, you need to have parentheses. Okay, so out, you don't have parentheses. It's not like this. It's not like, where's my cursor? You're not writing something like this, so it's not a function. This is just a field. Okay, now print line is a function. So you're basically invoking this print line from which is defined on this out, which is a field in the system. Okay, system is a class. Now question, when I run my hello world, if I don't have this system class, will my hello world able to run? Apparently no, right? Now same thing, what is string? Anyone know what is a string?
Also a class.
It's also a class, right? Same thing here. If I'm trying to run hello world, I also need string to be here. If for some reason I don't have string, can I still run my hello world? Obviously not. Okay, so does that mean to run my hello world, I just need these two classes to support me? No, there's a lot of things we need as well. For example, if you go to the system class, if you just drag to some random place, for example in here, now there's a class, there's something called level. What is level? Obviously it's a class. Okay, I don't know what is this level class, but this is a class, or I'm sorry, this is the enum. This is the enum defined in this class. Okay, I never seen this before. Let's drag to some other place. Let's say this logger. Okay, what is logger? Logger is an interface. It's also defined in here. Let me just find something. There's something. Yeah, let's say this property. Okay, this is a class. Now, this is a class. Let's say this. If I don't have this properties class in my system, can I run my hello world? Can I? We cannot. Okay. You don't have to understand what this property used for. Maybe some of you guys used this before, but if you don't have this class, then your system class will have a problem, because in the system there's a function called getProperties, and this getProperties function gonna return a type of this properties class. So if you don't have this class, then the system class will have a problem. If your system class is having problem, then your hello world is having problem. Okay, so what I'm trying to say is, seems like we're only running this little program we write in here, but actually behind the scene there's a lot of class we need, which is supporting us to run this program. Okay, and all those class, if you miss something, it couldn't run. So where are those classes located? When we run this program, do we have all those classes somewhere to supporting us? Yes. Where are they? On the left side, there's an external libraries. You can open this external libraries. You can see there should have your JDK 11 in here because this is the version you configured when you create this project. And open this, you can see there's a lot of folders. There's a lot of packages inside. Okay, so where is our string or system class located? You can go to the system. There's a button. This button on the left side is like a aiming scope, aiming sign. You can click on it. It will direct you to the place where this class is currently located. So system is a class located in this package called java.lamp. Okay, lamp, it means language. It's a very basic first package created by some company in Java. Right now it has been moved to different places, but anyway, it's in this Java lamp package. Now this package is currently located in the Java base package. Where this base package located is coming from your JDK, actually inside your jar file. Okay, so there's an rt.jar file. In the rt.jar, it has all these system or the string classes in here. So if for some reason I remove this JDK from my external libraries, will my hello world still able to run? The answer is no. Okay, you need all these to support you. So
I have a question.
yes.
So you're saying that if we miss some class in the system class, this program cannot run?
In the system, what can run?
So in order to run this class, right, we need a system class.
Yes.
So if we remove any or like random class in the system class, can this program run?
No. Okay.
Any class.
Any class. Let me give you an example. Okay. Let's say this.
Can you explain why so?
Let me give you an example. Okay. Let's say I have a class called A class, and inside I'm creating a B thing in here. Okay. Let's say public B. Now what is B? B is another class. Okay. Now inside this A, I'm having this public static void main function. Okay, I'm just short for main function. And now I'm having some code, system.out.println ABC. Okay. So now let's see this. After I write the code, everybody know you're supposed to run Java C and to generate this A.class and B.class. Then I can run Java A to start my program, right? Now the problem is when you run Java C against these two different files, you have these two classes generated. But before you run this Java A, you delete this B.class file. Okay, since there are two classes files. Now you delete this B, you directly run Java A. Is your program able to start? The answer is no. Okay, why is that?
The answer is no, but what if we remove the public B in the class A?
Okay, sorry, these are two different files. Two different files. Okay, so this A, we already said in one file we cannot have two different public classes, right? So since they're both public classes, they must be in a different file. So this is in the Java file A.java. This is in the Java file B.java. Okay, now after compiled, you will have A.class and B.class. What you're trying to ask me is if I...
So what I'm trying to ask is, let's say class A is system class, and in the class A we have public B, right? So if we remove public B, can it run?
Oh, if you remove this line, yes.
Yeah.
Yes, if you remove this line, yes. But the thing is, I do have this line here, right? Which
yes.
In your A, you need B. However, if I remove B after I compile it and I want to run this program in A, this will give me that class now found issue.
Yes.
Okay.
That part I understand.
Yeah, the same thing. The same thing here.
Yeah, in class system, right?
Uh-huh.
In system class, if you click to the system class, we have a lot of class, and then if we remove some part of it, can the system run?
Okay, first, the system itself doesn't run because this class doesn't have a main function.
Mhm.
In the system, there's no main function. If you want to run a Java program, you have to start from a main function, and main function is in a hello world. Now, even you remove something from the system itself, the system maybe it's okay. But I mean, when you come to here, well, if you don't need that function in the system, you can remove it. For example, you have a function in here you're trying to call full, and this function internally is trying to call be the bar function. For example, you have a bar function in here. Okay, you want to call be the bar. It's okay, but let's say if you remove this full function, now do you still care about this bar function in the B? No matter you remove it or not, you don't care about that anymore. Okay. So basically what I'm trying to say is hello world itself doesn't require the property or whatever things. But right now, since the system class require all those classes in here, it has the code in here to use all those. If you don't have, for example, you don't have the input stream, since you have this line in the system, this line will give you a problem. Okay, as long as you can understand this, you're okay. So what I'm trying to say is, seems like we only run our own little hello world, but actually there's a lot of classes you need to help you because the code is written currently like that in the JDK. If you miss any class, your code cannot run. So when you're trying to run a Java program, right now your hello world class is currently on the disk, is hello world.class, this file. Now you're trying to run this by running this Java HW. And what actually happens? The thing that happens is you're going to first make sure you have all the classes in your memory. Basically, let's say in your memory, you're going to have a piece. Just like in the actual machine, you want to run a game, you must install the game first. You want to run Discord, you must install Discord first. Same thing here. You want to run Hello World, you must make sure you have hello world.class inside. And to run hello world, you also need system.class in here. Without this class, your hello world doesn't work. You also need to have string.class in here. You also have properties.class in here. You also have that input stream, whatever, all different kind of classes which you need for whatever your program required, even including all those behind the scene. Okay, now once you have all this in here, then your class, then your function inside the hello world can be invoked. So to run a program, the first step is to put this class in here, and this step we call it class loading. Load the class loading. Okay, what is responsible for doing the class loading is class loaders. Okay, so here comes your first homework. I don't have enough time to talk about class loader. It's something you can research by yourself. So there are different type of class loaders in Java. Your job today is to read through, do some research, Google, to find out what are the different type of class loaders. What are they responsible for? What class are they responsible for loading? I mean, different class loader responsible for loading different classes. You need to know this, okay? During the interview, people may ask you knowledge about class loader. So do some research. Now, once all the required class is loaded inside the memory, the next thing you're going to do is to run the code. Now, to run the code, just like in the actual machine, to run the code, for example, you're trying to run a game. What do we need in the actual machine? We need a process, this little guy, okay? This little person responsible for run the game for us. This little person in the computer responsible for run my hello world. Same thing in here. In my program, there will have a little guy, a little person. Okay, this little person trying to responsible for running the code for me. Why we need a person? Because we know in Java, everything starts from the main function. Main is a function. Now, question is, can a function be run by itself? Or a method? Can a method run by itself? Think about this in real life. For example, I can say I have a function called walk. Okay, walk. What is walk function defined? I move my left leg, and then I move my right leg, and I put this in the loop. Okay, now this is a walk function. Now the question is, if I only define this function walk like this, will this function run by itself? It's not.
No.
Okay, who can run this function? Who can?
You.
People, right? Yeah, it's us, basically you, me, or whoever, person. So it means without a people, without a person, this walk function cannot be run. Same thing in here. Main. This main is a function. It's only defined, whatever in the main function only define you, like if this function is being run, what's going to be executed. It's basically the steps of this function supposed to do. Will this function run by itself? No. Now the question is, in a typical Java program, who is responsible for run a function? Anybody know?
JVM.
Well, I'm trying to find a more naive answer. Okay. All right. Let's say this. In the actual machine, who is responsible for running the game for you? We can say is this little guy, is this process. Okay. So what is game? Game is just a piece of code. You know, every computer program is written by some sort of code, right? So code is something stay on your disk. It will not run by itself unless you have a person to execute the code for you. This person, we say, is the process, which is called the person, okay? Same thing in our Java code. If you want to run your program, your main function, you also need a little guy to run things for you. In Java, we call this a thread. Okay, is there anybody used to write any multi-thread code? Anybody?
Yes.
Yes. Okay, good. Okay, I'm not sure if everybody else used to write any multi-thread code. Not very many people like to talk, but if you don't have too much experience, then most likely you don't. Okay, but in the first day of training in here, start from today, I want everyone to start to have the idea of thread. So what is thread? You can consider like a little guy. What is this thread include? It's basically the same thing like the process has. It contains some memory, usage of the CPU bandwidth disk memory, but it's basically not managed by the entire operating system. Instead, it's managed by our own Java application. Okay, so there will be a thread to run your program. So what is the very first thread? The very first thread, we call it main thread. It's not because of this function is called main, so we call it main thread. It's just the name of the main thread. Okay, now is this the main thread? No, this is the main function. You need to know that main thread and main function are different things. Okay, main thread is created by this Java program. So every time when you start a Java program, the first thing Java program will do is load the classes. And after the classes are loaded, second thing is he will create this main thread. Now, you have this little guy created. What's the job he's going to do? What this little person will do? This little person has only one job, is to run this main function. Okay, why it's running the main function? It's hard-coded in this guy. That's why every Java program, if you want to run it, you have to have a main function. Okay, if you change the main function to something like main1, will this still able to run? You cannot. You can see there's already have a error in here. It shows you don't have this main function. Okay, so this little guy's job is to run the main function. Now, how will he run? Same thing here. Look at this. In the actual machine, if a little guy is a process trying to run a game, he need to have his own memory, disk, everything. Same thing inside Java. If this little thread is trying to run a function, he will basically have his own area to run your code. And we call this a stack. Okay, now stack. Does everybody know the difference between stack and queue? Anybody?
First in, first out, and first in, last out.
Yeah, first in, first out, first in, last out. Okay, so stack is basically first in, last out, or so-called last in, first out. So why we call it stack? Because it's a stack structure. What it does is he will try to execute the main function, but he needs a place to put his code in here for him to run. So the code is originally loaded and saved in this class. But when he run the code, we know the code, seems like we only write these 2 lines. But after we compile, this entire code will be compiled to a lot of different lines of command. Now, for each thread to run, he will copy that command of this function into his own stack to run. Now, this stack is only visible by this one thread to run. Okay, basically, for each function, he will create a stack. So for executing the main function, he will have a stack for this. Now, let's take a look what's in the function. Inside the function, the first line we're saying is string str equals a new string. We already know, everybody I believe knows. New means we're going to create an object. Okay. Now we are actually creating a string object. String is a class. We're using this class to create an object. Now, where is this object created? Anybody know?
It's created in the memory.
In the memory, yes. This entire area is for my Java application to use. But to be more specifically, does anybody know where this object is being created?
On the heap.
On the heap. Where is the heap? I'm not asking on this picture, okay? Or does anyone know what is heap? Okay.
Is that also part of the process? Or?
Okay. What is heap? This entire memory assigned to our Java program is actually a heap area. Why we call this heap? Because the internal structure is a heap. You know, heap and stack, these are all data structures, right? So this entire area is a heap. But then why we call it with step is also in here, because we're using part of it to save our function information. And that little piece of memory is a stack structure, but the stack is also on this heap. Okay, so this entire memory, we call it heap, but for the stack, we just call it stack. So the other area, we call it heap. Whatever is not stack and whatever is not for loading the classes. This other area, we call it heap. So for me, easily to show on the picture, I will just demonstrate in this way. Okay, I will say this area, heap. Okay, so what happens is you're going to find this class string and create an object on the heap. Now this object is a string type of object. Okay. Now to be more specifically, I want to talk about this new keyword. Okay. Everybody know, use the new keyword, you can create an object. But what's the new keyword actually does? I'm gonna write the steps in here of the new. I'm gonna write it in here. Okay. Steps of new keyword. First step. When you new something, whatever you're trying to new is actually must be a class already loaded. If you don't have this class, can you new it? Let's say, can I new something like ABC? You cannot, because I don't have such a class. Okay, but I have string class, so I can new it. So the first thing we need to do for the new is to find the class we're trying to new. Okay. Now, second step. So we know that new is trying to create an object on the heap. We can imagine this as like we are trying to create a building of a house. So class, everybody knows, it's like a blueprint of something. For example, hello world is a class. We can use this class to create an object. String is also a class. It's a blueprint. Okay. So now we find this blueprint. The next thing is we're going to create an object on a heap based on this blueprint. So before we create this object, we actually need a piece of memory for this object to use, right? So the second step is just like in the real life, you're trying to create a building, is to allocate a piece of memory for this object. Okay. Now the question is, do you know how big this memory is required? Let's say this. When you create a string, do you know how big this string needs? Or I'm trying to create a hello world. Does the Java program need to know how big this hello world is? Actually, yes. Okay. This file is being compiled. This file is being loaded in here. To create any type of object, when you new something, system already know how big it is. Now the problem is, we know when you create a string, you can have question. Okay, so we know different strings. If I have hello world in here, or versus this long string, okay, a short string versus long string, they will have different size. Now the question is, if the string length can be different, when you new a string, does Java know how big of a memory this string is required? Do you know you need a space for 3 letters or 5 letters? Or is every string has the same size of memory requirement? When you allocate a piece of memory, the answer is actually all the strings have the same size. Now apparently it's like not understandable. 2 letters versus 10 letters, are they the same size? Well, if you look at the string class, you can see the string class look like this. This is string class. There's a field called value. This value is a byte array. So whatever the letters or things you're trying to put inside, you will be converted to a byte array and put it inside this assigned field. Okay, so if you draw a picture, you can say on the string you have a byte array called value, which pointing to another location. So your hello world, these letters or whatever the thing you're trying to save in this string with the exclamation mark is actually saved in this array in some other location. But the string itself, this piece, is the size of this piece actually changed based on the length of your string itself? It's not. Okay, so basically when you create a string object, each string object itself, this part, every string are the same. And how big this part is required? you can find from the string class. So when you new a string class, you need to allocate a piece of memory for the string only for this piece. Okay, so from this class you will find out how much memory you need. So a JVM or a Java application will give you that piece of memory. Now third, after you have this memory, what's the next thing you're going to do? You're going to create this object on this memory. Okay, you have this, or you can just simply say create the object. Okay, because we're using new, we're trying to create an object. So the third step is to create an object on this memory. Now the fourth thing is to call constructor to initialize the object. Okay, now I believe everybody know when you new, you're actually putting a constructor in here. Okay, we're going to talk about the constructor in future, in detail, talk about what is Java constructor, what's the feature of the constructor, but I believe everyone knows that before. So, but in here I want to mention that call constructor is only the last step of creating this object. Okay, so before you find the location, before you create the object, you cannot call the constructor, because the constructor is used to initialize the object. You have to have the object and then to initialize it. So the fourth step is to call the constructor. Now there's one more step at the end, but that step is not for creating. So after the first four steps, this object is done creation. The last step is to return the address of this object. Okay, you create the object on the memory, most likely you're trying to use it later on. So this piece will return an address. Okay, but where this address goes. So what is the address? Let's say this object uses a piece of memory on a heap. Now this memory he used is a continuous memory in here. Okay, now each memory space, each single memory space, it has a memory address. Let's assume, okay, this address start from 1000 and at 1050. Okay, end with here. Now, which address will be returned after you knew this string?
The 1000 one.
The 1000, right? This head address, we call it head address. If you learned C before, I'm pretty sure you know this. The head address will be returned. And where will this address goes? If you just create a string like this, for example, I don't have this equal mark on the left side, then what happens is you will return this head address, but nobody holds it. Okay. However, we have this equal mark. Equal mark in Java or in other language means assign. Assign mark means you're going to assign the right side of the equal mark to the left side. So what is on the left side? What do we call this? Anybody know? Okay, in Java, we call it a reference. Okay, so in C, we have variable name and pointer, different types, but in Java, we don't have pointer, we call it a reference. So what is this reference actually looks like? This reference contains these things. The reference contains three things inside. Basically, there do have some other things, okay, but the majority of things are these three, which is the type, is a string, the name of this reference is str, and the location. Now we assign it 1000, so the 1000 is the location. Okay. Now if we don't assign anything, for example, I just define something like this, string str1. Since I don't have equal mark after this, now the question is, what will be the value for this str1? Anyone know?
No. NULL.
Null, N-U-L-L. Okay. Now, here's a question. Does that mean you're going to have something called str1? No. No. Okay. If you don't have anything, by default, this will be 0. Why 0? Because this is a place for you to put a memory address. You can put memory address 1, 2, 3, or 1000 or something, but this place, you can only put a number inside. We will tell you what is the number, to be more specifically, what's the format in the future, but it must be a number. You cannot put null in here. Null is not a number. Okay, so by default, it will be 0. Okay, so for us right now, we assign a value, let's assume it's 1000 to here. So this str in here currently have this value 1000. Okay, now the next line, what you're doing in here is you're calling system out of print line, which apparently is a function. Print line is a function since you have parentheses in here. And then you pass this str into the function. So this str is this reference representing this 1000 thing in here. It actually means is pointing to this location. Okay, now you're passing this to this system.out.println. Now system.out.println is a function. To call a function, we need another stack. Like this. For example, we're calling the main function. The main thread is trying to call the main function, so he will create a stack for this main function's execution. Now the same thing. This println is also a function. To call this function, we also need a stack. Now the question is, who gonna execute this function? Anybody know? Who will execute
Another thread?
Another thread? No. Okay.
Main thread.
The main thread. Why is that? Because the main thread responsible for executing the main function. So his job is to finish every single line inside this main function. Now, one line inside this main function is print line. Of course, the main thread responsible for executing this function as well. Okay, today we're not talking about anything like multi-threading. We're not. So actually, whatever we're going to talk today, all executed by this one single thread, main thread. But you need to know it's not this main function. Okay, this is the main function, but the main thread is created by this. Is this guy, this person? Okay, so since he's responsible for executing the function, and this function requires a stack, so he will create a stack inside the stack. Okay, and inside the stack, he will execute this println function. So basically, what he's gonna do is he will copy this function to this little stack and to run. Now, for this little stack of code to run, he need to pass. We are actually passing this str to this function. Okay, so you passed this str inside here, means you're passing this address 1000 to this function. Now inside this function, he will, whenever he needs this object, he will know this object located on 1000 location. So I'm not talking about the detail inside the print line, but this function will grab this string and display whatever you save it on this value. So that's why you can see hello world is displayed in here. Okay, so basically what I'm trying to show you in here is in this entire memory, we have a piece of area to store all the class information. We can say these are the class level information. Okay, and we also have some place we call it stack, is a structure stack, to store some information. And what are these information stored in here? These are thread level info. So basically, for any thread to run something, they will have their own stack. Okay, so in the future, if we're trying to talk about multi-thread, so what's mean multi-thread? Multi-thread means there will have another thread. I'm not going to draw a little guy in here. I just use this heart to represent a little person. Okay, so I will have another thread. And in Java, we cannot just create a thread without telling him to do anything. Thread, since it's a worker, is a guy. This guy exists only for work. So if you're creating a thread, you need to assign him a task to work on. So this thread need to work on something, most likely a function. So to call a function, he will create a stack. So basically, each thread will have his own stack to manage whatever he's going to work on. Okay, if I have multiple thread, I will have multiple thread with their multiple stacks. Each thread have its own stack. So right now, since we have only our main thread, so main thread has its own stack to run the main function, and inside we run system out, you're going to have another stack. Okay, stack inside another stack. So stack, we can say, is trying to store the thread level information. Now, what is on the heap? Heap is trying to store the object level information. So basically, in this entire memory assigned for my Hello World program, we can say these are the basic area. There do have a lot of other area. For example, the method area, the register, the counter, all the other things. We're not focusing on those small pieces. We just focus on the big picture of this memory area. Okay, so basically, this is what this memory looks like. Now, if you compare this actual machine, in the actual with the picture I draw down here, in the actual machine, you want to run something, you're going to have all these programs installed on your disk, and then the operating system get whatever you're trying to do. The operating system will create little guy, which we call process, responsible for running the thing on the memory or on its own places. And then you run any program, this little process is responsible for doing that. Now, in our Java program, same thing here. You need something, you have to load it first. And then if you want to run something, you also need to have a little tiny process, but we just don't call it process anymore in our Java program. Instead, we call it a thread. So we're going to create a thread, and the thread is responsible for running the program or the function you have in your class file, run it on the stack, every different. So in the actual machine, we can have multi-process to run at the same time. In this Java code, we can have multi-thread to run at the same time. So what is this? We can say this is our JVM, is our virtual machine. Okay, so what is virtual machine? Virtual machine is actually a concept. It's a concept helping our Java developers to understand how our memory is located. And some people like to call it JMM, means Java Memory Model. Okay, so no matter you call it JVM or JMM, it's the same concept to help you to understand how is Java program actually manage the memory and how to manage the thread. Okay, so this model, this picture, I'm going to draw a lot in the future when we learn Java backend. And to understand all these mechanism inside will help us a lot to understand how our Java code is actually running. Okay, so we need to know the class level information, the thread level information, and the object level information. Okay, so what is this part called? So originally, this entire JVM are split by different in different areas, and we call it different generations. Okay, now this area on the left side originally is called permanent generation. Permanent, how to write permanent? Maybe there's some typo inside. Okay, anyway, permanent generation. So originally, when we load the Java class, load in the permanent generation. But after Java 8, start from Java 8, it changed. We still have permanent generation inside our JVM, but we're no longer to load the class into the permanent generation. Instead, we're going to load the class in a place called metaspace. So what is the difference between metaspace and permanent generation? We're going to talk later, okay? And it's only a small difference. But right now, as long as you remember this is what JVM, then is good. Okay, we're going to use this picture a lot in the future training. Now, I'm going to ask you a question. Hope people can answer me. How many JVMs do we have in my computer? Or in your computer? Anybody?
Is it just one or one per Java program?
Is a choice or?
You can have as many as you want.
Yes. Okay. So the second answer, again, you said is correct, and also whatever you guys have said is right. So as long as you have a Java program, you will have a JVM. Okay. Some people may think you will have only one JVM for one computer. No. Okay. Every single running Java application, you need a JVM. So this is what JVM, and this is what a basic Hello World is trying to do here. Okay. I hope you can remember the steps of new in here. Any questions so far? Okay, if there's no questions, then I'm gonna give you a slice. Okay, let me see, where is the slice? I'm gonna put it on the general channel. Slide. You can download and zip it. Inside this slide, you will find different folders, and one of the folder we call it Java. And inside Java, you can find different PowerPoints. And let's open part 1 OOP. Part 1 OOP. So this PowerPoint is not created by me or not created by your instructor for the front end. You see it's created by Dr. Peter Xiong. Who's Peter Xiong? He is originally working, he originally worked for Mercury. So right now he's no longer with Mercury anymore. He created all these slides. Okay, the Peter, your instructor Peter to train you the front end is Peter Jiao. He's not this Peter. Okay, so Peter Xiong, he's created all these slides, and he's no longer with Mercury, but the slides are still great, so we're still continuing using that with his permission. So basically the structure he did is, if you look at the slide 6, page 6, you can see there's a lot of concepts on here. Okay, and start from page 7 all the way to the end of the slides. It's trying to explain every single concept in here. So all these concepts are common asked during the interview. Okay, so we need to clarify everything in here. So right now what I'm going to do is I'm going to unhighlight everything, and whenever I talk something, I will highlight it. At the end, we're supposed to finish everything. Okay, now, but let's start from the page 2. Now, page 2 is basically a basic hello world. What it's trying to tell us is what a hello world looks like. Okay, just like, where's my Java code? Okay, just like this. So some small things I want to everyone to pay attention. First is the name has to be the class name. Second, like I said, you cannot change the main function's name. If you change it, means you don't have the main function. Okay. Third thing is, can I change some other things? For example, Can I remove the static? Will this okay? If you remove the static, looks like your code still okay, but your program cannot run. You can see there's a problem again. You click on this button, it will show you the issue. Okay, so you need a static. Now the argument. Can I remove the argument? Same thing. Okay, it will show you issue. Now I don't remove the argument. Can I just remove this? Change from a string array to a normal string. Can I? No, it will also give you issues. Okay, is there anything I can change on this line? Yes, there are two things you can change on this line. First is the name of the argument. You can change it to X, Y, whatever. It doesn't matter because args is just an argument name. You can change it. Okay, second thing is you can change this. You can change it to here. Okay, this is also you're defining an array. Okay, but normally when people define an array, we put the bracket in front inside here. Okay, so there's another way you can use 3 dot in here. Anybody use this before? Nobody? Okay, so this represents you can give me 1 or you can give me 0 or 1 or multiple strings in here. Okay, so by default, this string array in here means you can give me different strings and you can I can receive those. Okay, but when we run our main function, do we give any arguments in here? Normally we don't. Now how can we pass in arguments in here? So if you're using command line to run this, you can run like this, for example, Java A, and then you can have some arguments in here, A, B, C, D, E, F, whatever. Okay, all these will be part of the args. Now, if you're using IntelliJ to run it, how do I give arguments? So you can see when we run a main function, we actually click on this button, but the hello world, but whatever you're running here is actually a configuration created in here, hello world by default. And you can click on this edit configuration. You can see this hello world is an application which we were trying to create it manually by clicking on this application in here. Okay, now in this hello world, you can see there's a line called program arguments. So what is this? Whatever you put in here will be passed into this args. Okay, so even in the IDE, you still have a way to pass in this parameter. So basically, this is hello world looks like, and inside the hello world, you can have more than one classes, but you can only have at most one public class. It has to be the class name. All right, this is the basic knowledge of this class itself. And page 3 and 4 is talking about OOP. I want to talk later. But right now, I want to talk about our first concept in these topics. Okay, I'm not going to talk everything from top to bottom. I'm going to probably run big. But the first one I always start with is this, static and non-static. Okay. Now, what is static? So static right here is a keyword. Okay, so I like to ask this question during the interview for you guys to join Mercury, because this is one of the basic things to see, do you understand about JVM? But most people who ever trying to answer this question is just trying to say the static is make things global, make things class level, is all right, okay? But I like everyone to answer a question in this format. So no matter they're asking static or asking something else, I wish you could answer in this way, like briefly tell me what it is. Okay, so briefly tell me what is it. Second is how or what or whatever. Okay, explain in detail. So Now we're talking about static. What is static? Static is a keyword. Okay, so I've interviewed a lot of people in Mercury, but everyone else answering this question directly tell me static is a globe, can make it global or something. There's only one candidate which is currently in this room is telling me exactly the same thing I'm going to talk right here. Okay, static is a keyword. First, you can see this is a keyword. Static and void or public, whatever in this color is all keyword. Static is a keyword, can be added in front of something. What is something? For example, in front of this, in front of a field or a function or a inner class or a code block, or directly call it block. Sorry, just call it block. Okay. Static is a keyword. This is the first thing you should talk about. And second is it can be added in front of this. What are these? We're going to talk shortly. So to make it class level. Okay. Basically, once you add static in front, this thing become class level. And if you're not adding static in front, by default, we call it non-static. And non-static means it's object level. So let's talk about these first. What is a field? Is str a field? No. We can only say str is a variable. Okay. So you can, for example, you can define int x equal to 1 in here. Now you can only say x is a variable. But what is a field? If something you directly define inside a class, let's say this, int y equal to 2. Now this y, you can also call it a variable, but you can also say this is a field of this hello world class. Okay, something you directly define within a class, under a class, you can call it a field. But something you define in a function, no, you can only call it variable. Okay, so you can add a static in front of a field. For example, instead of in front of this y, you can add static. But can you add a static in front of this x? You cannot. Okay, so variable you cannot add static, but a field you can. Now, what is a function? For example, main is a function, or I can create my own function. Now, talk about function. Function also called a method. So, what a function looks like? Everybody already used a lot of function. Function, including these part. The first, we can say public. No matter we have static or not, let's say no static. So no matter you have public or static, these things, we call it modifiers. Okay. Now after the modifier, we will have a void. Now what is void? Yes, suddenly remind me. I didn't have any break this afternoon because we start at 3 o'clock, so it's almost 5:30, so I'm going to continue. Okay, we're not going to have any break today. So void is the return type. Void. If you don't want to return void, you can return int or something else. Okay. Now after that, you should have your function name, for example, foo, and after that you will have a parenthesis to represent your argument or parameters, and then a curly braces to represent your function body. I'm going to use void in here. Okay, so basically you're going to have modifiers plus your return plus your function name and plus a parameters or arguments, and after that you will have your function body. Okay, now modifiers. What modifiers can we have in here? For example, public, static, final. We're going to learn a lot of this, synchronize, all these. Okay, all these are modifiers. Now, can we switch the order of these modifiers? Yes. For example, you can put synchronize in here. You can put static in here. It doesn't matter. Okay, doesn't matter about the order. But is void a modifier? No. Void is the return. Can we put void in front of something, some modifier in front? For example, I put void in here. It's not gonna work. Okay, so the void is the return. The return has to after all the modifiers. The modifiers you can change the order, it doesn't matter. And after that you will have a function. Now some of the function in here you can throw something. For example, throw an exception. Okay, not all the functions require these throws. But if you have, you can throw it in here.
What are you up to, man? Stay at home. You're a stay-at-home cat. Pussy. You're a stay-at-home pussy.
Can you
Yeah,
mute? Okay. So this is what a function looks like. Okay, the modifiers, return, function, name, and everything. So in the function, in front of function, you can add static, or you don't have to add static. If it's not static function, then it's class level function. Sorry, it's an object level function. You add static, it makes it to be class level. Okay. Now, next, what is inner class and what is block? Inner class is something we're gonna talk right after we talk about static, right here. Inner class, also called nested class. Okay, so during the interview, no matter what people is calling it, you're supposed to know what it's talk about. So what is inner class? Inner class means inside the class, you can define another class. For example, I can have another class, public class A. Okay, so this is an inner class. Now, is this an inner class? So after the class, I'm defining a class B. Is this an inner class? No, it's not. Okay, this is just a regular class, but it's not public. So inner class means a class defined within another class. Now, in front of this inner class, I can put static as well. Okay, so yeah, I'm saying the static can be put in front of an inner class, but can we put static in front of a not inner class? If it's not inner class, like this hello world, we always call it just a normal class, or if it has an inner class, we can call it a outer class. Okay, so can we put static in front of a normal outer class? You cannot. Okay, you cannot. So that's why I only mentioned inner class in here. Now, beside the inner class function field, we also have something called block. What is block? So inside the class, you know you can define y or x, whatever in here, but can you do something in here like this? For example, I'm going to sys out 1 to 3. Okay, I can put this sys out 1 to 3 inside the main function or inside the full function. But can I put this line directly in the class like here? You cannot. Okay, in Java, you can define field or define things in the class, but you cannot directly put your executable code under a class. It's not going to work like this. Okay, so you cannot put it in here, but there's beside the function itself, is there any other place I can put my code in? Yes. For example, in this class, you can directly write a curly braces. And inside this curly braces, you can put your code. You can even put multiple lines. Okay, whatever lines. Now, what are we calling? How do we call this? We call this a block. Okay. Now, this block, in front of this block, we can put static. If we put static, we call this a static block. Okay, static block. So basically, where can we put a static? Inside the class, whatever the element we can have in a class, we can put our static in front. Okay, inside the outer class, we can have an inner class, we can have field, we can have block, we can have function. So all these we can put static in front. Now, can we put it in front of an inner interface? Let's say this, public, you can have inner class. Can we have inner interface? For example, interface B. Okay, can we put static in front? Of course you can, but you don't have to. Okay, but anyway, what I'm trying to say is, as long as this thing can exist inside a function, inside the class, then you can put static in front to make it class level. Okay, so basically static is a keyword that can be added in front of all available elements. So how to spell this word? Available. Yeah, available. Okay. All available elements. So this is what static does. Now, what's the difference between class level and object level? That's the key point. Okay, we already know it make it class level. So what's the difference? The difference is, if you still remember this picture, we said all the class level information will be loaded at the very beginning when you start your Java application. Okay, so actually, inside your JVM, there's a special area called a method area. Okay, in this method area, you're gonna store all the method of all the class, no matter it's static function or non-static function. All the functions are here. Okay, all the functions. But to help us easily understand the thing, we can say this. For the class, for example, I'm gonna delete the other classes. For example, my hello world. Okay, I can draw something like this. So I can say, hello world, I have a main function in here since it's static. So I can say the static function main is loaded in here. And also I have my static function foo loaded in here since they are class level. But also, let's say if I have another function called public void var, it doesn't have static in front, so it's an object level function. Now I will put this object level function when I draw the picture. Okay, I'm going to put it in here, var. It is part of the class, but since it's an object level function, you cannot use it. Okay, static function is class level, so the class level information will be loaded before the thread is actually working on, before your runtime. Okay, so runtime means when we have our thread created and the thread is starting to work on your code. That's the time we're calling the runtime. So in the runtime, our thread will start working on. Now, before every thread start working, we have to make sure whatever the thread required has to be loaded already. That's why we need to load all the classes in here for the runtime. So we can say the static functions, since they are class level, so they will be loaded with all the class together, and they will be available to call at the very beginning. Okay, so that's why the main function has to be static. Because if the main function is not static, it means this function is object level, which means you can only run this function from an object. But at the very beginning, there's no object yet. You only have this little guy, this main thread is waiting for running the main function. He doesn't have any object, but he needs to start the main function. So this main function has to be static, means this function has to be already available for this guy to call. Okay, so that's why the main function has to be static. So when the code is running inside the main function, can we execute the foo function in here? Yes, you can. Why is that? Because foo function is also static. Static means this function is already loaded inside our JVM. It's a class level information already loaded. So that's why whenever this main thread is executing the main function, if he's trying to call the foo function in here, he will try to find it from this class. Can he find it? Yes. because this is class level function, so he will be able to call the full function. Okay, now can we directly run a bar function like this in here? Can we? No. Even the bar function is within the same class, but we cannot run it. Why is that? As the picture I'm drawing here, the bar function is non-static, means it's an object level function. Object level means you can only call this bar function from an object. But do we have an object of this class right now? We don't. Okay, you're not calling the bar function from some object. You're directly put this line here to trying to tell the code that I'm going to invoke this function directly within here from this class. But bar function even is defined in this class, but it's not class level, so you cannot call it. Okay, I want everyone to have this clearly understand. Since it's non-static function, so it's object level, so you can only call it from an object. Right now you cannot call. This is the bar function and full function. Okay, now you're talking about, you may think I'm talking about how to call this full or bar in the main function. Now inside the full and bar, can they call each other? Let's say this, inside the full, can I call bar? And inside bar, can I call full? It's the same thing actually. Okay, so inside the full, can I call bar? You cannot. Why is that? Because full function is class level, is already loaded at the very beginning, before runtime. Okay, full function is available. Now inside this function, if you say you want to call bar, now the problem is he doesn't know where is the object. Okay, he cannot call it. If you really want to call it, how to call it? You can do this. You can create an object, hello world object, HW equals new hello world. And from this object, hello world, then he can call the bar function. Okay, so bar function is object level. Object level function can only be called from an object of this class. So HW is a reference referred to a hello world object. And from this object, you can find a bar function. Okay, but you cannot directly call it like this. It's not going to work. Now, let's see. In a bar function, can we call full? Apparently, yes. So why in bar function we can call full? Because we already know bar is an object level function. Whoever want to call this function, you must have a hello world object created. For example, somewhere on a heap, you're having this hello world object. Let me move it a little bit. Okay, let's say somewhere, someday, some people create a hello world object. This object is hello world. So I can say on this object, I will have my bar function in here. Okay, since it's an object level function, so I just directly put on this object. But am I going to put full function here? No, because full is a static. It belongs to the class only. I'm not going to put it on the object. Whatever I put on the heap is the object level information, and bar function, I put it in here. So whoever has the pointer, has the reference refer to this object, from this reference, he can call bar function. Let's see this. I'm going to create just like what I did in the full function hello world, and I can call hw.bar. Okay, means I'm trying to invoke the bar function through this object, from this object. So why the bar function can call full? Because no matter who is trying to call this bar function, when that happens, when the bar function is being called, which means you already have this object. Now, if you have this object, means you must already have this class loaded. Okay, you want to create a hello world object, HW, you must already have this class. If you already have this class, if this class is already loaded, means the full function is already loaded as well, since it's class level. Okay, so which means whoever trying to call the bar function, when the bar function is being called, full function must already exist. So foo function always loaded or available to call before bar. So inside bar, when I call foo, it's okay. Because in the bar, you make sure foo function is already available. But inside foo, if you want to call bar, it's not, because bar can only be called if you have an object. But inside foo, by default, you don't have the object. Okay, now why in the main you can call foo? Because they are loaded at the same time. Now how about this? If I have another function called public void test. Okay, this test is also a non-static function. Now in the test, can I call bar? Yes, you can. Okay, so in the foo, I cannot call bar because it's an object level function. But why in a test I can call bar? I mean, some people answer me like, since both functions are non-static. But why both functions non-static you can call each other? It's the same thing in here. Because since the test function is non-static, I'm going to write it in here. And this is the object level function. So this function will be shown or will be available through this hello world object. Okay, so now in this object, can you call bar? Of course you can, because whoever is trying to call the test function, you must already have this hello world object. In the same object, you will for sure able to find the bar function. Okay, that's why in the same class, if these two are both non-static functions, they can call each other because they are surely be available at the same time. Okay, so this is the static keyword on a function. Now, static keyword in front of some other things are similar. Okay, for example, a static field. Let's say if I have a, let me remove this. For example, if you have a static int x equal to 1 or static int y equal to 2. Now, inside the main function, I'm going to delete the bar in here. Okay, inside the main function, main is a static function. Can I use x? For example, I'm going to sys out x. Sorry, I have an x defined in here. I'm going to remove this. Okay. Can I directly display x? You cannot. But can I sys out y? Yes, you can. Why is that? Same thing, because the main function itself is static, means this is a class level function. This function will be available whenever the class is loaded. At the time, do you have x? No, because x is object level. This field only appears in any hello world object. But you're not having an object in here. You didn't say hw.x. For example, hw is a hello world object. On this object, you can find x. But if you're not putting hw in front, you just directly put x in here. He doesn't know which x is coming from. So you cannot directly use x like this. But for y, it's okay, because y is static. You can say y directly appears on this class. Okay, so that's why you can directly use y. All right. Similar thing also you can find out in the block and in the inner class. We're gonna talk those in different topics. Right here, I just talk a little bit about the static function and field. Okay. This is pretty much the thing we're gonna talk about today. Okay, I'm gonna share this picture, this entire thing, this general channel, just for you to reference. Okay. Is there any questions so far?
Any homework today?
No. Homework I already gave you one, right? You forget the homework?
Yeah, the class loader, like, how do we submit it?
Okay.
Or we don't need to submit anything?
I hope everyone, okay. if in the future, if your homework is to write a program, you can submit your you can put your program in a jar file or put it in a zip file, whatever. If it's just question answer, doing some research, you can put it in a Word file and upload it in here. Or let's see, tomorrow we will create a folder or somewhere on Google Drive and ask you guys to upload it in there. Okay, but today, everyone, whoever finished the homework, you can put it in this, just drag and drop in here. Okay? I encourage everyone to do this homework. Just write your answer in a Word document. You can do research and use your own word to describe it and put it in here. That'll be good enough for now. Yeah, Peter said he will create a Google Drive folder and send a link in here. Okay. If the Google Drive you can see, then you can also put your answer inside there as well. All right. Any question so far?
Do we need to submit a report for today?
Yes, please. And submit it to this address. I believe you already have it. This address. Okay. Tag at Mercury Systems. Remember, there's an S inside. Systemsinc.com. Okay. All right. If no other question, and I hope everyone learned a little bit at least from today. And if there's no other question, then see you guys tomorrow at 10 o'clock Eastern time in the morning. I hope everyone can be here on time because we have more than 20 people. I don't want to wait for somebody all the time before the class. Okay. If no other question, then that's it for today, and see you tomorrow.
Sorry, where can we find the report form?
On the top, I don't know if you right here on the very top.
Very top? I don't. Oh, okay. Is that?
Lost the report. Very top. Here. At today, 11:35 a.m. Peter sent a report.
I see it. Okay, thank you.
Okay, no worries.
Yep.
See you tomorrow at 9:30 or 10.
10 o'clock we start the class.
Okay.
Okay, so I'm probably not gonna wait too much time tomorrow. Just hope everyone can join the class on time. All right.
Thank you.
All right, thanks.
Yeah, thank you very much.
Thank you.